Hello, everybody. You enjoy your meal? It was okay? Well, so my name is Mathieu Calba. You can find me on some social network here. And I work on Android for a company called Capitaine Train, and we are selling train tickets across Europe. And we've launched our Android application at the beginning of this year, and this summer we launched even a companion app on Android Wear. So before going to the technical stuff, I'm going to tell you a little story. So this is a story about Julien. He was searching for an app to manage his bank account. Fortunately, he couldn't find the one that meets his needs because they all seemed broken. Why? Because they always needed an internet connection, which was very painful, even just to check his leisure budget and what he had, kind of money. So this made him very angry. It just needed a simple debit-credit managing app with a good backup. So he had an idea and decided to create his own app, focus on user experience and simplicity. Yes, I know it's kind of a cliche, but not everyone can do his own app, but just for the purpose of this talk. So, what does this app need? Well, it needs a great app backend. What I mean by a great app backend is represented by this schema. We always have a server side, and we have our mobile application. They communicate with each other through an API, and to allow very good flexibility on the UI side, you have to separate the UI from the backend in your app. So basically, you have all your activities, fragments in the UI layer, and you have another layer called app backend, which contains all your data, how you communicate with the server. And this helps you have very, very good flexibility at the UI level. Then you can test a lot of implementation for the UI, for the UX. And when creating the Capitaine Train Android application, we wanted to make the best possible experience for the user, from the backend to the visual interaction. That's what we wanted, always have the data up to date. For instance, a user can purchase a ticket on his computer from his work, and he doesn't need to take his phone out of his pocket to update it, to check if he really has his ticket on his mobile phone. The app updates itself, and the user doesn't have to think about it. So that's what syncing is all about. Well, now we're going to a little dive into the technical stuff. So what syncing is, it's executing a simple background job to update local data when appropriated. What is a background job? First, it's non-user-facing operation. It involves upload or download operation. It always requires network connectivity. And for the important part, we need to always leave the data in good state. Otherwise, the user can have a very bad feeling because his app is broken. There is nothing displayed on the screen. So, when it is appropriated to do a background job? Well, it's also known as scheduling and triggering. We need to only update when needed. That means not too often, not less often, and when relevant. That means we need to take into account the network availability, the battery levels, and other means. We also need to restore after a reboot, because if the user, we schedule a sync and the user reboots his phone, when he reboots, our app hasn't launched yet. So we need to reschedule it. So we need to think about how to handle it. we need to handle a potential external backoff technology, so we can postpone if we don't have the different needs that we need. And we need to be careful with the battery life. And the when appropriate part is very, very important, because it can lead to very, very bad user experience as he installs our app and our app is draining all his battery. What are the possible solutions on when appropriate? Of course, the best solution is push messages. Well, push messages is not always available depending on your on your server. If you don't own the server, if the server is not your part of your work and you have a lot of other things to take care of before doing push notifications. So the fallback is periodic polling, which is bad, but we can be clever. By being clever, determining when to do a sync, we can improve it a little bit. So, how are we going to do this? The Android way? Well, the Android ways, because there is always 1,000 ways to do it, but what is the right one? So, first, we're going to see a simple solution with an async task to do the work in background, of course, and we use the Alarm Manager to schedule a periodic polling and periodic scheduling of our task. We need to use the set in exact repeating method to schedule a periodic polling every hour. We need to, unfortunately, the Alarm Managers only use pending intent. Pending intent are just like an intent, but to be fired in the future. So we need to use Android components that are started by intent. We can have service, receiver, and activities. Here, we're going to use a receiver in order to launch our runnable. So we create our receiver, then we declare it in the manifest. So it's a lot of boilerplate code. What we can see here is that the async task and receiver can be replaced by an intent service for simplicity, but that's not all, and there is a lot of other things to taking care of, like restoring a periodic sync after a reboot. For this, we need to use a permission to restart our application when onboot completed is called. Then we need to reschedule the periodic polling using the Alarm Manager by looking for a local cache where is saved our state of the different schedule that we had. We also need to handle connectivity availability, so we just need to check if the connection is available before starting our async task, and if it's not available, then postpone our wake up. We need also to indicate the sync state to other. Well, that's a lot of work again. So one other solution is the SyncAdapter. I don't know if a lot of you know the SyncAdapter, but it's a good solution. We'll see more in details in the next coming slides. So the SyncAdapter, it's one method to do the upload and download sync. The SyncAdapter part, but it's done only for one data provider, a content provider here, associated with a user account. That means an account authenticator, which can be triggered by manually or by the system. And this is where its benefits lies. So first, we need to create an account authenticator, but not every app needs an account, and the user doesn't need an account for every app. So basically, we can create a stub account authenticator. So we return null or throw unsupported operation to different methods. Not a lot of boilerplate code, but nothing more to do. And we need to bind the authenticator to the framework by using a service. and we return it in the onbind. Then we need to declare it in the manifest, and we need also to configure it. So we need an XML files, account authenticator is, and this XML files, I don't know if you can see it because it's right below, but the important part is that we need an account type corresponding to our account authenticator. And then we need to add the account required by the framework, because the SyncAdapter only works if for one account or many other accounts. So we need to create a fake account for the user. So when we start our application, we need to look into every account that are available for our account type. If we found one, we don't need to do anything. Otherwise, we need to create a fake account for our account type with a fake account name. So this is how we do a fake account authenticator if you don't need it. But if you need a real account, like, I don't know, a Capitaine Train account, then you can look into this website where Udinic worked on Cal.2 and other applications, explain how to write a good account authenticator. Then we have the data part. So we need a content provider. Not everybody likes writing content providers, but because there are a lot of boilerplate codes, but you're not forced to use them. You can use a stub content provider. Basically, you have almost nothing to do except implementing the method with return null almost each time. Then we need to declare our content provider is a manifest. With the important part here is that we define an authority. We don't want to export our data because it's a fake account, a fake content provider, so we don't need it. And it's syncable. That's an important part for the SyncAdapter. So if you want to know how to create your own content provider, you can go see my slide at this URL. And now for the SyncAdapter part. This is where the fun begins. So we need to create a SyncAdapter, which extends abstract-seeded SyncAdapter. Basically, we have one method to implement here, onPerformSync. onPerformSync takes an account, the accounts for which our sync was needed. We have a bundle. It's some data that are provided by the system to understand, for instance, if it's a synchronization from scratch or a diff synchronization, that you can put your own info here, and you can put, and the system is going to put some info for you, like it's upload-only sync, it's manual sync, etc. We have also the info of the authority and the content provider client. Be careful, the content provider client, it's not like you used to use a content provider. It's just a very direct access to your content provider. And this direct access does not handle multi-threading. That's an important part. So you need to be careful when you use directly this attribute, because you can have other part of your applications that will use the content provider and will clash with your use here. So basically, you can better use context.getContentResolver, then you're going to use the correct implementation with the handling of the different threads. And last but not least, you have the sync results. The sync results is going to contain the metadata about how the sync was done here. So you can indicate if the sync was a success or not. You can indicate what kind of error they were, and then ask for a reschedule of your synchronization. Then you need to bind the SyncAdapter to the framework, just like Account Authenticator, you need a service, and in the unbind you need to pass your reference to your SyncAdapter. If it's a service, you need to declare it in the manifest with the intent filter and the action SyncAdapter, so the system can trigger your SyncAdapter. And we have a little metadata here with SyncAdapter. It's very likely the account authenticator. So here we have the account type. The account type, it's the same account type as you used in your account authenticator. Allow parallel syncs is used for allowing the system to schedule multiple synchronization across different accounts. So it can be a little tricky depending on how you handle your data for different users if you have different users. You need to precise your content authority. Is always syncable is an attribute that helps you indicate the systems that once you create an account, this account is automatically syncable for the user. Otherwise, it's not syncable, and the user won't see the potential automatic sync. Support uploading indicates that you want to use a support uploading methods to trigger synchronization mechanism for your SyncAdapter from your content provider. We're going to see it later. And finally, you have user visible, and this parameter allows you to not display your SyncAdapter and the account associated with it in the settings app. And as we have a stub account and a stub content provider, it's better to not display it to the user because it's just a technical stuff, not a real stuff for the user. If you want to trigger the sync, well, you just have on the content resolver to call the request sync for one account, for an authority, so your provider, and you have some metadata that you can add. In the metadata here, we have one solution. If you want to trigger a sync later, we don't know when, you can just pass null or new bundle. If you want to trigger it now, immediately, then we need two parameters. First, the extra manual, we need to set it to true because we want to, in your backoff and settings of the user, to bypass some configuration the user can add. And second, we need extra expedited in order to put the request at the front of the queue. That will trigger the notification right away, the synchronization right away. But then, if you want to have a periodic sync or auto sync when the network is up, that will help you, and the system will trigger automatic update of your SyncAdapter. You can do this by calling two methods. First, you can use the setSyncAble method to force an account to be syncable. When you can do this when creating an account. This is the Java equivalent of the XML parameters that I told you about just before. And then we can use set sync automatically. This is what the system uses to trigger periodic synchronization depending on the system availability of the network. So basically, the system works like this. You have a persistent connection to Google servers through GCM. So we can, to maintain this connection, is send packets regularly between the server of Google and your device. So this will batch multiple SyncAdapter synchronization with this network exchange. Then we can choose to add periodic sync. It's another solution. You can use both one or another. And the periodic sync will be for an account, for an authority, of course. You can have some metadata to add. And finally, you need to precise when to do the periodic sync. We need to be careful here. It's in seconds, not milliseconds, like any other API in the Android framework. So otherwise, you will have strange feeling because the periodic sync won't happen. And finally, you need to be careful because the user can have a widget to disable automatic sync. Then your automatic sync or periodic sync won't work. So basically, you're screwed, and you can't do periodic sync automatically using the system when it's configured like that. It's a widget here. You need to be careful because sometimes I have an emulator that is Wacom, that is launched, and synchronization is off, and you don't know why it doesn't work. It's because there is a settings that is like this. Well, I told you before that one very important part of the SyncAdapter is to trigger synchronization from the content provider. Data changes. So this can be very useful. For instance, in Capitaine Train, we have some options the user can put on some tickets. So when the user wants to delete an option, this doesn't have anything meaningful on the server side to be done. So maybe we can do the deletion right away without calling the network, just locally, and then a little later, the SyncAdapter will be waken up to do the real API call. First, for doing this, you need to implement a real content provider, of course, because basically your data will be stored really in the content provider. So you first, when a delete is requested, you need to know if the sync to network, if this URI is a sync to network URI, and if this is the option ID, so that's a URI for calling one option in the delete. And then instead of just deleting the item locally, we just mark it as deleted with a column called sync deleted, and we mark it as deleted. Basically, we put an integer 1 here, and we update our data. Otherwise, we just delete the data correctly. Finally, for the sync to happen, we need to inform the SyncAdapter that a change has occurred and that it needs an upload sync. For this, we are calling notify change on an URI. This notify change on an URI will trigger a notify change of the content resolver, but only if needed. So basically, we need to know if the URI is upload ready. That means the same thing as before if the user has a sync to network parameter and if we are option ID. Otherwise, it's not an upload ready URI. And we need to be sure that the SyncAdapter is not the caller of this request, because the SyncAdapter can call the deletion of an item, and then it will trigger him to inform him that the deletion has happened, and he will re-trigger it later, and it can lead to some bad calls. So we need to check if a parameter is added to the URI to indicate that it's the SyncAdapter is calling. And this is how we do the query parameter thing. So it's just basically a query parameter that we add on the URI to indicate via Boolean if the caller ID is a SyncAdapter or if the caller ID has sync network information. But be careful, there is one part important here, is that your corresponding query should not return the deleted data, well, the mark to be deleted data, if it's not the SyncAdapter querying, of course. And well, that's all. So the SyncAdapter, it's kind of the Google way to do it. There are other companies that are using it, like Evernote, like Capitaine Train, and many others. It's easily triggered by the system when appropriate, network availability change associated in the content provider and other things. But it needs an account authenticator, it needs a content provider. So basically it's a lot of boilerplate code, like too often on Android. Maybe we have another solution. Another solution might be the JobScheduler new API that was introduced in Android L. What is the job scheduler? Well, basically, it schedules the execution of a job via a service with various parameters about when the execution should happen. The should is important here. We'll see why later. Because we can use a window of time, periodically, sync to network needed. Basically, it will be careful to batch different calls to the job scheduler across all the systems. So it will batch different jobs for different apps together to optimize battery life for the device. How are we going to do it? So we need first a job service that is going to do the work. We have two methods: on start jobs and stop job. Where we know on start jobs, it's when we have a new job to do, and on stop jobs, someone has requested that the job with the job parameter given was needed to be interrupted. But we need to be careful because it's a service, a simple service, not an intent service or otherwise. So we need our own executor or another multi-thread solution to do the work because we don't want to block the user. And the job parameter only contains the job ID, an integer, and identifying the job, and some extra we can give him. Then we can have, for instance, a little task which implements runnable, which takes some jobs parameter. It will do the work in the run method. When we are finished, that's a third important part of the API on the job scheduler. We need to indicate that we finished our job. So basically, we need to repost it to the main threads. That's what we use, a handler and other task. And when it runs, it's called job finished with a job parameter and the info if the job was successful or not. It's important because the system can use different techniques to reschedule the job in the future. Because it's a service, we need to declare it in our application. But we have some permissions to add. First, we need the permission bind job service to the system to allow to use us. It needs to be exported because otherwise the system won't see it. By default, their services are exported, so that's not a problem, but I wanted to point it out. And finally, we can use the use permission on our application. This will allow the system to reschedule the different jobs after a reboot of the user. It will put in a cache the list of jobs, and then it will trigger once again the jobs when needed. Now for triggering the different jobs. First, when we want, it's really simple. You need to get a reference to the job scheduler through the get system service, and we need to schedule a job info. A job info is built using a builder with one ID. It's the ID of your task. It can be a fixed one or different, or one that is updated depending the time. And we need to schedule it on our job service. That's why we pass a component name linked to our job service. And then we have different parameters that we can have. So first, I'm going to show you the set backoff criteria. It will allow you to specify the backoff criteria used. So basically, here we specify a backoff criteria of every minute after the job has been terminated without a success for him to be rescheduled, and with a technique of exponential. There is also the linear technique that is available. We can set a minimum latency in order to let the system wait at least here 5 seconds before triggering our job. We can have a deadline of 1 hour here. We can request the network capability. Here we can request any network capability because by default they are not requested. And another example is for triggering a periodic job. So we have an ID, we have our job service reference, and we just set periodic with the period. Here, 1 hour. And here it's really in milliseconds. And finally, we can add other things like unmetered network connectivity needed. We can require the device to be idle or to be in charge. And it's just some example. Do not take them like a real piece of code that you can add to your app. Well, the JobScheduler seems very great. It has a lot of pros, like configurable scheduling across all the systems between different apps, and that's very good for battery life. It's a simple service, so it's very efficient, and we can use persistent state to reschedule our jobs. But it's Android L plus only, unfortunately. But it can be improved, I think, with using possible retro-compatibility libraries that we can build based upon service and AlertManager, just as I've done before when I've shown you the first solution. You can create a limited compat library, not using the benefits of sharing jobs schedule across all the system, but in your own app. So maybe Google will provide us a compat library for this in order for us to use it, because otherwise it won't be used for at least 2 years, so it will be a little unused. And we have also the solution of the SyncAdapter, which is perfect if you have an account and a content provider. Otherwise it's good, but it's a lot of boilerplate code to add. What we've shown here is that we have the tools to create an app that works seamlessly without an internet connection. So the user never have to worry about its internet connection. And that's an important part, because then we can improve our UX to let the user do like anything in the app without even worrying about how it works behind. No refresh button to force the user to refresh our data. Do you have any question? Yes, it will be available just after the Oh, okay. Well, the API documentation, you have to download a zip for the Android L preview, and then you can have access to all the API. Otherwise, there is not things available on the internet.
Also, I have a second question. It's about the service that you use, the
yes.
service that you have to extend. Is there any notification displayed to the user when the service is running?
No, nothing is displayed to the user. It's just a service.
Okay, it's a service that's completely visible.
Yes.
Even if it runs while the app is running.
Yes.
I think I saw you start a service in the SyncAdapter.
No, we bind the SyncAdapter with a service, because the system uses this service to access to the SyncAdapter. Basically, the system binds to this service, like a bound service, and then it will ask for triggering this SyncAdapter.
Okay, thank you.
Hi, thanks for the talk. Are you planning to have a job scheduler